Hello guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about how we solve equations and inequalities of modulus functions by using the method of first of all removing the modulus signs, then equating the left hand side with both the plus and minus the right hand side. So I'm going to do that by looking at this example. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So for this example, we need to solve the inequality modulus of 4x plus 3 being greater than the modulus of 2x minus 1. So we say we shall remove the modulus signs, then equate the left hand side to plus or minus the right hand side. So we're saying 4x plus 3 is equal to 2x minus 1, 2x minus 1, right? Or 4x plus 3 is equal to minus 2x minus 1. Then we shall solve for x. So here, taking x to the side, 2x is equal to minus 4, then x is equal to minus 2, or we've got 4x plus 3 being equal to minus 2x plus 1, then 6x will be equal to minus 2, such that x is equal to minus a p. So we've got these two solutions for x, but we need to find the range for which this is to be valid. So we shall come up with a number line, right? And we shall take just random values. So here we know we've got x being minus 2, so if we take minus 3, and then we know that here we take minus 1, and then we know we've got a minus third, then we take a 0 as well. So the x increases to that side. So if we take x is equal to minus 3, right, we see that here we've got minus 4 plus 3, which is minus 9. Modulus of minus 9 is 9, right? And then minus 3 here, we've got minus 6 minus 1, which is minus 7. Right, so 7 is definitely greater than, 9 is definitely greater than 7. So it means the region for which x is less than minus 2, right, we need x to be less than minus 2. And then for this critical value here, x is equal to minus a third, we're saying that if we pick 0, right, we're saying when x is equal to 0, we've got 3 being greater than 1. Which is what we want. So we also want the region when x is greater than minus a third. So these are the two solutions for x that we have, right? The two inequalities that we need. So now let's quickly look at those questions, number 1 and number 2. Allow me to erase this. Okay, so for number 1, we're asked to solve each of these equations algebraically. So the first one, for A, we've got 2x minus 1 being equal to plus or minus x plus 2. So we're saying 2x minus 1 is equal to x plus 2, or 2x minus 1 is equal to minus x plus 2. Then we solve for x. So here we're saying x is equal to 3, or 2x minus 1 is equal to minus x minus 2. Then 3x is equal to minus 1, and x will be equal to minus a third. So either x is equal to 3 or x is equal to minus a third. And then for part B, we're saying that 2x minus 6 is equal to plus or minus 3x minus plus 1, such that 2x minus 6 is equal to 3x plus 1, or 2x minus 6 is equal to minus 3x plus 1, right? Then solving for x, you are saying x is equal to minus 7, or 2x minus 6 is equal to minus 3x minus 1, such that 5x is equal to 5, then x is equal to 1. So either x is equal to 1 or x is equal to minus 7. Then moving on to part C, we're saying x plus 4 is equal to plus or minus 3x plus 1, right? So such that x plus 4 is equal to 3x plus 1, or x plus 4 is equal to minus 3x plus 1. Then we're now saying 2x is equal to 3, such that x is equal to 3 over 2, or x plus 4 is equal to minus 3x minus 1, such that 4x is equal to minus 5, then x would be minus 5 over 4. So either x is equal to minus 5 over 4 or 3 over 2. Then moving on to part D. For part D, we've got 5x minus 2 being equal to plus or minus 2x, such that x minus 5x minus 2 is equal to 2x, or 5x minus 2 is equal to minus 2x. Right? Then we are saying 3x is equal to 2, such that x is equal to 2 over 3, or 5x, in actual fact, 7x is equal to 2, such that x is equal to 2 over 7. So either x is equal to 2 over 7 or 2 over 3. So this was simply looking at number 1, part A to part D. Now let's move on to look at number 2. So allow me to use this. Right. And then now for number 2, we are solving for the inequalities. Right. So number 2 says solve each of these inequalities algebraically. So for the first one, we've got 2x minus 3 being less than x. So first step, we shall find the critical values, right, by saying 2x minus 3 is equal to plus or minus x, such that 2x minus 3 is equal to x, or 2x minus 3 is equal to minus x. Then x would be equal to 3, or 3x is equal to 3, such that x is equal to 1. So we shall use these critical values to find the range for which this inequality has to be valid. So we shall say on a number line, if we pick 0, 1, 2, 3, and then 4 here, then we've got our x. Right, so if we pick 0, x is equal to 0, we are saying that minus 3 is less than 0. That doesn't make sense. So we don't need a range whereby x has to be less than 1. So definitely we need x to be greater than 1. If, for example, we pick 2, we're saying that 4 minus 1, that's it. 4 minus 3, that's a 1. Then 1 has to be less than 2. So that is correct, right? And then now for 3, if we pick 4, right, we are simply saying 4 times 2, that's 8. 8 minus 3 is 5. 5 can't be less than 4. So definitely we don't need a value whereby x is greater than 3. So we need x to be less than 3, such that we're saying x is greater than 1 but less than 3. So this is the solution for 2a. And then now moving on to the last part, which is 2b. First of all, we shall find the critical values, which we say x plus 3 is equal to plus or minus 2x plus 2. Right? Then, so this for part B. Then x plus 3 is equal to 2x plus 2, or x plus 3 is equal to minus 2x plus 2, right? Then we shall now solve for x, right? So we're saying x is equal to 1, or x plus 3 is equal to minus 2x minus 2, such that 3x is equal to minus 5, and x would be minus 5 over 3. So now we shall use these critical values to come up with the inequalities that we need. So on a number line, if we put minus 5 over 3, right, and then we put minus 2, minus 1, 0, 1, and then we put a 2 here, as x. So for this critical value, let's say we pick minus 2. So we're saying minus 2 plus 3, that's a 1, right? And then minus 2 times 2, that's minus 4. Minus 4 plus 2, that's minus 2. So now 1 can be greater than or equal to minus 2. So we don't need any range which is for x which is less than minus 5 over 3. So we need x to be greater than or equal to minus 5 over 3, right? And then for x is equal to 1, if you pick 2, we're going to say 2 plus 3 is 5, right? And then you say 2 there, 2 times 2 is 2, plus 2, that's 6, 2 times 2 that's 4, plus 2 that's 6. But now 5 can be greater than or equal to 6. So we don't need a value, we don't need the range for which x is greater than 1. So x needs to be less than or equal to 1. Right, for x is equal to 1, we'll be having 4, right, and then 4. So of course, 4 is greater than or equal to 4. So the final answer will be x being greater than or equal to minus 5 over 3, but less than or equal to 1. So this is the solution that we need for part 2, part B, right? So this was looking at how we would solve equations and inequalities of modulus functions by using the method of first of all removing the modulus signs, then we equate the left-hand side to plus or minus the right-hand side. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.